Hello friends, very good morning. A hearty welcome to my channel. And friends, in this video, we are going to work out a problem on the power screw, which is also called a screw jack. And let's see what the question we have for today's video. The question reads like this. A load up to 500 kilonewton is to be raised at a speed of 6 meters per minute by using two screw rods and with square thread of 50 by 80 So it is a screw thread, a square cross section, and the dimensions are given. And he says determine the torque required to raise the load. Friends, the best method is you will start from part A and see what are the contents of that part A, and we'll solve these step by step. In the first part, he said determine the torque required to raise the load. Friends, if you go to the machine design data handbook, the formula for torque required to raise the load is given by mt is equal to w d2 by 2 tan alpha plus mu divided by 1 minus mu tan alpha plus mu c dc by 2. This is the expression available in any of the machine design data handbook on power screws. Friends, let us find out what are these terms stand for. So W is the load. Friends, the load is given to be 500 kilonewton. And remember friends, this 500 kilonewton, which is 500 into 10 to the power of 3 Newton, is being shared by two screw rods. So we have to design each of these rods. They all have the same dimension. Therefore, W on each rod is equal to, this is 500 into 10 to the power of 3 divided by 2 because there are two rods. It is 250 into 10 to the power of 3 Newton. That is the load acting on each of the rods that are being used to raise the load. Then next comes D2. D2 in this expression stands for the mean diameter of the screw rod. So that is D mean dia. That is nothing but the average of outside dia D, inside dia or core dia D1 by 2. Then how to find out this? Friends, it is given that the square that's used are 50 by 80 Friends, here if they write 50 by 8 into SQ, it stands for a square thread of 50 millimeter outside air. That is D is equal to 50 and this value 8 is equal to pitch. And you know very well the outside diameter D is equal to inside dia plus pitch for a square thread. And hence this is 50 is equal to D1 plus pitch is 8 and hence this D1 works out to 42 That is the core diameter. So you will be able to find out this as this is 50 plus 42 divided by 2, that is 40, 50 plus 40 to 92, 92 is 46 That is the mean diameter of this. So we know this we know the load on each. Then comes friends, tan alpha. Tan alpha stands for the term lead over pi d2. If you refer to handbook, this tan alpha is equal to lead L by pi d2. What is the meaning of lead? Friends, if you have a nut, a screw rod and a nut, this lead is equal to pitch. That means if you have a nut, if you give one rotation to the nut, keeping this stationary, the distance advanced by the nut on this length of the rod is called the pitch. So lead is equal to pitch for single start thread. Lead is equal to twice pitch because they given here, and this is to have to by motor determine all these values, and here this lead is equal to twice pitch assuming double start thread pi into d2 we know, and this is 2 times pitch is equal to 8 divided by pi into 46, and friends, you get the value of this tan alpha 0.1107, 0.1107 is the value of tan alpha. And next comes mu. Mu is the coefficient of friction between the rod, screw rod, and the nut. So here if you refer to the data handbook, corresponding to the screw rod made of steel and the nut made of bronze, you have to take the starting coefficient of friction, and using heavy machine oil, it will have a value of 0.147. Mu is 0.147. This is again obtained from the table. Then you have got mu c, coefficient of collar friction, that is generally 0.1107. You can refer to handbook and find out the value. Then comes this DC. Friends, DC stands for the mean diameter of the collar. In some of the problems, maybe outside they are given of the collar, inside diameter, you can average it. In the absence of such a data, you can approximate this value of DC as 1.5D, that is 1.5 times 50, that is 75 millimeters. So you will be able to obtain what is DC. Friends, you know all the quantities on the right hand side of this equation, and you should be able to obtain what is the value of this MT. So you will be able to find out what is the torque required to raise the load. Friends, let's move on to the second part of the question. It says, what is the speed of rotation of screw? It's a very important part. Say friends, we have got a screw rod like this, on which threads are cut, and we have a nut passing over that along the axis. This is the rod and this is the nut, say like this. And this nut has to cover a distance of how much? That is speed of rotation of this. So the pitch is given to be like this. So it has to cover a distance of, say how much? A load of so is to be raised by 6 meters per minute. So this is to be 6 minutes. So this is a distance, say from here to here is 6 meter, and it has to be covered in 1 minute. Let's see how many rotations this nut is to be given to obtain that value or to pass through this distance of 6 meter. Friends, you have already learnt the meaning of the lead. So it is a double start thread. That means if you give one rotation to the nut, to this nut, it will advance through the length of the screw rod by a distance of 2 times pitch. Pitch is 8 mm. So in one rotation of this the nut, it will cover a distance of how much? 2 into 8, 16 mm. So to cover this distance, what is the time required? Or at what speed it has to rotate? So friends, we can write down here, lead is equal to twice pitch. That is equal to 16 mm, because pitch is 8 mm. That's given in the data. The meaning of this is, give one rotation to nut, it will move down by say 16 mm. But we have to cover 6 meter in 1 minute. Therefore, to cover 6 meters, we need to give 6,000 millimeter divided by 16. So many revolutions. So that will be how much? That is 375 revolutions. So we have to give 300 revolutions to cover this distance of 6 meter on the thread or the screw rod. Friend, this distance is to be covered in 1 minute. So this value becomes, therefore RPM or speed of rotation is 375 RPM, because so many revolutions are to be made in 1 minute, and hence the speed of rotation of this is equal to 375. This part is very, very important, and in most of the question, this is how they give you the second part of the question. Friends, let us move on to the maximum stress induced in the rod. Friends, you know this screw rod is subjected to two types of stress. One is due to the load, that is the compressive stress sigma. Other is the torsional load. So we have to find out both the axial load, which is compressive in nature, and the torsional load. So, and friends, you can write down here the maximum stress. I can say maximum stress, maximum stress in the rod is equal to, this is tau max, is equal to half of square root of sigma square plus 4 tau square. So this is the formula we have got, again available in the data handbook. Friends, here this sigma is equal to sigma C compressive stress, that is W by AC. Friends, W on each you know, and what is the core area? Friends, here AC stands for the core area. They have given us the outside dia, they have given us the pitch, we know the inside dia. So I'll write down this as pi by 4 d1 square. So this load is given to be how much? It was 500, means 250 into 10 to the power of 3 Newton divided by pi by 4 into d1 is 40. That is, yes, d1 is 42 mm square. Friends, you get this value as how much? Sigma C is 165.74. 165.74 MPa. Then friends, this tau is equal to mt by zt, the torsional stress. Mt by zt, mt value we know, zt is equal to pi d1 cube by 16, that is I by C formula. We just you will get it, and you will be able to find out what's the value of this tau. So by substituting these two values, we will get the maximum stress in the rod is equal to a value 188.72. 188.72 Newton per mm square. That is the maximum stress induced in the screw rod, which combines both the compressive stress and the torsional stress or the shear stress. Friends, we will move on to the next part, the efficiency of the drive. Friends, for the screw rod or screw jack, the efficiency is given by the formula. Efficiency is given by the formula d2 times tan alpha divided by tan alpha plus mu by 1 minus mu tan alpha into d2 plus mu c dc. Friends, this equation is available in the data handbook, so you need not by heart or memorize it. Friends, we know all the values here. D2 value we know, we have got as 46, tan alpha we have calculated, mu c, everything is known, and hence if you make the substitution in the formula, you get a value of 0.264. So this value works out to 0.264. When converted to percentage, it becomes 26.4%. Generally, the efficiency of this drive will be very less on account of the friction involved between the nut and the screw. Finally, friends, we are required to find the length of nut for supporting this load. Friends, the length of nut or height of nut, we'll say here, the length of nut, which is also called height of nut, is given by the formula Ln is equal to I into pitch. the number of threads into pitch, or directly this equation is available in MDH in the following format as 4WP divided by sigma B dash by d square minus d1 square. Friends, all these are available in the data handbook. I can use this value, find out I and put, or both are same. Friends, we know these values. This is 4 times, this is 4 times, W is 25 or 250 into 10 to the power of 3 Newton because there are 2 rods, which is 8 mm divided by sigma B dash. Friends, sigma B dash stands for the bearing pressure between the screw and the nut. I told you in some of my previous videos that when this value is not given, the value usually used either for the bronze nut or for the cast iron nut, the value of the sigma B dash has a range between 12 and 17. So I will take this value as 15 MPa. Phi is known to us, d square minus d1 square. D square means the outside diameter of the thread or the nominal diameter which is given in the question as 50, that is square, minus d1 square. d1 square is the diameter of the core of the screw rod, that is 42 mm, that is obtained by subtracting 8 millimeter, that is pitch, from the basic dia, the nominal dia. Friends, if you substitute this, you will get an answer of 330 millimeter. So Ln is equal to 330 millimeter. And this is, friends, how we obtain or design a power screw when it has to lift some particular load at a given speed. Friends, please go through the complete video and do not skip any part of the video in between. And if you like this video, do share this video and my YouTube channel link, namely Engineering Drawing and Machine Design by Dr. M.H. Annaya, with all your friends without fear. And friends, in case if you have not subscribed to my channel, please do it today or at the earliest. Thank you very much for watching my YouTube video. Have a blessed day.